Hello and welcome to today's video. I've got some unfortunate news. I'm pretty sure I killed the microcontroller in the air-cooled DMOC645. If you watched the previous video, I figured out the byte that I needed to change, and I figured out checksum. It's ready to go. I actually wrote a bunch of code here to be able to modify it, but the first thing I was going to do is just read out the content of the EEPROM. I'm going to call it an EEPROM even though it's a flash memory chip. But yeah, I was just going to read it out, verify that the bytes that I read were what I saw through the logic protocol analyzer, and before I was going to switch it over and actually write to it. So I actually had I had this on the debugger, just still sitting down here. This is my, if it'll focus, it's a little motion controller, does 8 servos. And I had repurposed it, I had programmed it, I clip leaded it over with the clip leads here onto the same wires that I had soldered on to the EEPROM chip that I did all the sniffing with the logic. And I had, when I was running that, when I had the logic hooked up, I noticed that it always reads from the EEPROM, and SPI's out a multi-master protocol, so I needed their micro to stop reading the EEPROM. And I noticed that if you go into CC Shell and go to Tools and then click Place DMOC in Programming Mode and hit Yes, that actually stopped reading the EEPROM because it was in the programming mode. And I was like, oh, that's perfect, that's great, that's all I need to do. And so I had done that. I went and told my chip to read it out, and it was flashing the red LED on here, which means it wasn't getting any data back what it expected. So that was my little error code. It was just blinking the red LED. And when I was looking into what was wrong, because I thought maybe something was wrong with the code, all of a sudden there was the DMOC 645. I heard all the relays click, and I was like, whoa, what was that? Because it was in bootloader mode, it was shut down. And I think even though it's in bootloader mode, their micro was still driving the S-clock and master out, slave in lines high, while my microcontroller was also trying to drive them, and we had a bus contention, and my microcontroller won, and it killed the micro that's in the air-cooled DMOC 645. This is what it does now. If I flip it on, it lights up battery empty and error, and it doesn't communicate at all. I can't even get it to so if I kill this and try to run hyperterminal, you get nothing. I can turn it off, you get like a little character, turn it back on, nothing. That's it. So I think I'm pretty sure I killed the micro. Not quite sure how I'm going to fix that. Might have to buy another board if I can find one. But yeah, I can't even. If I put it in programming mode, it can't talk to it. So pretty sure it's dead. I got nothing. So I think in order for this exploit to actually work, which I believe this exploit will work, but in order to actually implement it, you're gonna have to take you're gonna have to unsolder the EEPROM, or the flash memory chip, from the board, program it, and then solder it back in, because I haven't found a way to make the I thought that was going to tri-state the outputs on the microcontroller so that I could take control of the bus, but apparently not. So it's very unfortunate, but yeah, I'm pretty disappointed in that, because I was really hoping that it would be that simple. Just hook it up, read out the that page, change the byte, recalculate, checksum, and write it back, and it would fire up and we'd have a spinning motor. But unfortunately, that's not how it worked out, so I'm going to have to go figure out how to fix it. But I'm pretty sure it killed at least 1 or 2 pins on the microcontroller, and it just hangs. It won't even boot up now. So yeah, kind of unfortunate. Thanks for watching.